Hello, student. We're going to cover today Chapter 1, Section 5. Okay, Section 5. Analyzing a graphs of functions. So we're gonna look at vertical line test, find zeros over functions, determine interval on which functions are increasing or decreasing, determine relative maximum and relative values of a functions, determine the average rate of change of a function, identify even and odd functions. Well, well, x, we know is independent variable that along the x-axis value. Then the vertical one, it is y, which is the same as if I said function of x. This means the same things. So if you take a distance along x, which is the x value, then you go up by the y value, or fx. So the function is y equal fx. So you have this point coordinate x comma fx, or you can say x comma y. But sometimes we do this function of x for convenient. This is a graph kind of limited. It doesn't go to infinity. What is the domain of this graph? Well, I need to find the beginning of x and the end of x. So this is the beginning and this is the end. So the value, so domain is, or value input x is, because this is a black circle, I'm going to say this value is included. This is -1. And you keep going until 5. This is a 5 value. 5, is this included? No, it has a white circle. So I use a curve. That is the domain. What is the range of this function, which is mean the output? This is mean output. Okay. So if you look in here, the lowest value is here, which is -3. Is it included? Yes. The highest value is also 3. So it is going from -3, +3. Both of them are included because they are black circles. Now they are asking us to evaluate, or whatever the value, what is if -1? So I need to go find the -1. This is a -1. How much is the y? Is 1. Here is the point. That's 1. How about f2? Well, this is the 2. If I go straight down, this is the value. 2, -3. That's the point. A vertical line test, that means if I sweep a function by a vertical line and the interception only 1 point, that means what I'm having is a function. So as an example, if I have a function like this, if I sweep a vertical line anywhere, I have only 1 point of interception. That makes it that is a correct function. But if I have a weird looking something like this is not function because the vertical line has 3 interception. So this is no a function. This, yes, it is a function. 0 of a function. Well, 0 basically is another name. This is exactly for x-intercept. Same as x-intercept. So we do the same thing. The only thing we are gonna say our answer and saying x-intercept, we say the zeros. So basically, to get set function of x equals 0, then find x values. Okay, so if you have a multiple value x1 comma 0, x2 comma 0, x3 comma 0, I mean, we may have one. These are the x-intercept. However, we're gonna call them zeros. We'll see an example in a minute. Okay, find the zeros for this function or the x-intercept. So you can see here's a function, we call it fx, we call this one g of x, we call this one ht. All of this mean function, doesn't matter the symbol we're using. So here function of x, function of maybe the time. Okay, let's start with the first one. We have to say that fx equals 0. Then we say 0 equal 3x squared plus x minus 10. To do this one here, that's the process. You multiply those two numbers. 3 multiplied by negative 10 give you negative 30. Okay, let me leave this gap here. Okay. Now, I'm looking for two numbers, a plus b, equal to the coefficient of x, which is 1. And those two numbers, if I multiply them, I get negative 30. Where do I do them? I'm going to say equal 0, open parentheses like this. Because I have here, remember, when we don't have a 3 in the function, we just say x. But because we have 3x squared, I'm going to write here 3x instead of 1x. Okay, now if I got those two numbers, I'll put them here. So there is multiple ways to get 30s. If I say 10 times 3, it is 30, but 10 minus 3 is not 1. So what other option? Other option is 6 and 5. So I need the 6 to be positive, and the 5 is negative. Now 6 minus 5 equal to 1. 6 multiplied -5 is -30. Here we go, we got it. Now we have two solutions. Two solutions. This equals 0 or this one equals 0. Three x plus 6 equals 0. Now I'll take the 6 to the other side. Then we get 3x equal -6. Divide by 3, you get x equal -6 over 3. So x equal -2. Okay. Your other solution, well, basically this is x -2. This is the first 0. The other one is 3x minus 5 equals 0. Then 3x equal 5. Divide by 3, x equal 5 over 3. Then we say 5 over 3, comma 0. This is the other 0. So those two are zeros. That's what you have to tell me in the test. These are the zeros. That's the final answers. Okay, we got this one first done. Let's do the second one. I have a function equals square root. So we're going to set g of x equals 0. That means equals square root -x squared. Basically here, whatever inside square root of 0 is 0. So whatever inside must be 0. So we're going to write 0 equal 10 minus x squared. Now, if I take the x squared to the other side, we get x squared equal 10. Now, x equal positive, negative square root of 10. We can use a calculator to get the exact answer. What are the zeros? Negative square root of 10, comma 0. And square root of 10, comma 0. These are zeros. The third one here, we said h t, we set it to 0, as equal to 2t minus 3 over t plus 5. We know because this is a fraction, t plus 5 should not be 0. So the only thing can be 0 is the top. Top equal 2t minus 3 equals 0. Then 2t equal 3 by taking negative to the other side. Then t equal 3 over 2. Now 3 over 2 comma 0 is 0. If we wanted to plot the first one, we have the x-intercept, which are the zeros, but we need one more point, the y-intercept. How do we get the y-intercept here? If I say x equals 0, then f0 equals negative 10. So 0, comma negative 10 is y-intercept. This is always easy point to get and helpful in plotting. You can do the same thing in here. If you said x equals 0, then g of 0 equal square root of 10, because the x will be 0. So y-intercept 0 square root of 10. Okay. If we need to plot the middle one, let's have room for it here. If you wanted to plot the square root 10 minus x squared, if you notice that the x-intercept, our negative square root of 10 is about 3.3. That's negative square root of 10. And the other one's the positive square root of 10. What is the y-intercept? Is also square root of 10. Well, basically, this is going to be a circle. If you connect, you're going to look like that. It is a half circle. Why don't we just don't we have a lower part? There is no negative answer for g of x. This should be always positive. Okay, because it's a domain. So it's only half circle. Let's see the other one, how we plot it. You're gonna see it. Okay, here's the plot. And the first 0 was 2 comma negative 2 comma 0. The second 0, 5/3 comma 0. If we plot them here, that's the x-intercept, our 2 point. Then what did we say about y-intercept? Y-intercept was 0 comma negative 10. Now if I connect, and this is facing up because we have a positive answer, positive x squared. Because positive x squared, this is going to be parabola like that. So we connect with parabola in that direction. You can see 3 point x-intercept, y-intercept is enough to plot your graph roughly. That's the other one. We said half circle because you don't have the bottom one, no negative answers. This one, we can still plot this one. What was this one require more, will involve. There's something here called asymptote. We'll learn it later on. It doesn't tell us nothing about it. The only thing we know, this is our x-intercept. And you can find y-intercept. If you say t equals 0, what do we get? G of, oh, it was h, okay. H of 0 equal, this becomes 0, 0, negative 3 over 0 plus 5. So it's become negative 3 over 5. That is the y-intercept. So negative, you say here 0, comma, negative 3 over 5. Well, this seems like less than 1. If you look at the graph here, it is the point. That is the point. 0. All right. This is the point here, this one. And you connect them, but how do you know you go all the way down like that? We'll know that later because you have an asymptote at x equal 5, negative, or yeah, negative 5. Increasing, decreasing function, that's kind of common sense. We always read the graph from left to right. So when we do that, this function is going down. At this, from this point to this point is going down, is decreasing. Then become constant, going flat. Then after that, start to go up, is increasing. So visually, it's easier to tell. as an example, if we want to understand what is increasing, this function continue to increase, no turning point, always increasing. This function starts by increasing when we reach the plateau on top, the maximum point, then turn around and start to go down. Then find another low point that's called critical point and start to turn around about it, then start to go up. So increasing, decreasing, increasing. Last one is, we did something similar. This function is 3 legs, 3 parts. From here to here is going up. Then it's constant. Then it's decreasing. Relative maxima and relative minima. So these kind of like, if I have something like this, so all of this on top called relative maximum, everything at the bottom called relative minimum. So if I isolate this area only without looking anywhere else, you see this is your maximum, this is your minimum. If I isolate this area, this is maximum, this is minimum. So that's the reason we call them relative maximum, relative minimum. Average rate of change. Of a function. That's them. They should add this function. Okay, this is y. This is x. So if I have a function like that, y equal fx. If I have a point here on the graph, this distance is x1. And the y value, well, let's do it this way. So at this point, this is y1. So the coordinate of this one, x1, y1. If I take another point, x2, y2. Okay. Remember that y1 is equal fx1, that means evaluation. Y2 is equal fx2. If I connect those 2 points with a straight line, what is the slope? Rise over the run, change in y, which is y2 minus y1, divided by change of x. Well, that's the slope of the line. Also, this line approximate the function changes from this point to this point. That's called rate of change of a function. So it's going to be using, it's kind of an approximate way saying how much we are changing along the graph by approximated by equal to the slope of a line. So the smaller the curve is, like if I have something like that, so if I go from here to here, this is almost a line. So the rate of change, ROC, equal y2, we say this fx2 minus fx1 divided by x2 minus x1. So this is the rate of change formula for any graph between 2 points, going from one point to another one. And that's all used also in stock market by saying rate of change, like if prices changes like this, and you say this is roughly the graph and this is approximate change from here to here. Example, they give us this function fx x cubed minus 3x. They said find the rate of change ROC question mark from x1 equal -2 to x2 equal -1. So that's the question A. So the first was the formula. The formula said ROC, the rock, is equal evaluation of fx2 minus evaluation of fx1 over x2 minus x1. So let's calculate the value. We know the x2 and x1, but we don't know the value at x2 and x1 of the function. So right, let's see here. So f x1 equal f, what, how much? -2 equal, we have to use this formula here, -2 cube minus 3 multiplied by -2. This is equal -2 cube, that's gonna use your calculator, -8. Negative is +6, that's equal what? -2. Okay, so for the summary here, we can say fx1 equal -2. We got it. Now, the second one, fx2 equal f, what was the value? -1. And that's equal -1 cube minus 3 multiplied by -1. And this one equal, -1 is going to cube, will stay -1. Now negative here, negative is +3. The answer is +2. So the fx2 equal +2. Now we're ready to plug in over here. How much fx2 is 2? The formula have negative. Always carry, put the sign from your formula. Then what is the value of fx1? Was -2. Now, x2, how much is x2? Is -1. Minus, how much the value of x1 is -2. Let's see what happened here. Negative become positive. Now you have -1, +2, because negative is positive. That's equal 4 over 1 equal 4. Function is increasing, going up, increasing. That's it. We got the value going for the rate of change. From this point, we can see that graphically it's really positive. Now, if I calculate the rate of change from along this line here and here, from this point to this point, you can, we must get negative answers. That is the same process as the question. From x1 equals 0 to x2 equal 1. So you have to evaluate. So this is B. You have to find out what is F0, which is, if you do that, you're gonna get 0. And what is F1? F1 is equal 1 cube minus 3 multiplied by 1. And that will give you 1 minus 3, that's -2. So for B, the rate of change, -2 minus, oops, minus what? Minus 0. Minus 0 over 1. What is the first value? Minus 0. The answer is -2. Oh, it's going down, decreasing. Okay, that's the rate of change to approximate how is the function is changing. Even an odd function. I mean, as simple as this, any functions that have x cubed, x, if it have an odd power, generally speaking, is odd function. Now, if you have x squared, x to power 4, x to power 6, when you have an even power, you're getting even function. So what is this function here? X cubed, that's odd. How about this one? That's even. They are showing some calculation. I'm not gonna worry about it. It's not really important. Okay. No, I don't need to do that right away. Here is an example. You can practice this. Find the zeros. You can write it down and practice it. It is in Canvas. You can find it in Canvas. Find the rate of change. That's exactly those two exercises for section 5. So at this point, we'll end chapter 5.